If you look at pages 26 and 27 of your journal, that's what we're going to be talking about in this next example. We have vertical and horizontal translations, left and right, up and down, and we're also, looking on page 27, going to see reflections in the x-axis and in the y-axis, where we plug the negative inside. You can also take a look at horizontal stretches and shrinks and see how they affect the graph. Looking at your notes in example 3, we want to have g be a graph, a function that is a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down. So starting with my f of x function, I know that a vertical stretch by a factor of 2 multiplies my f of x by 2. I also know that a reflection in the x-axis makes this whole function negative on the outside. A translation 3 units down is plus or minus 3. It will be minus 3, and that's going to be my new function. So I can say g of x equals negative 2x squared minus 3. To identify the vertex, I take a look at my hk. Technically, since there's nothing with the x, it's like x minus 0 squared minus 3. So remember, my h is in the parentheses, 0. My k is outside. So my vertex here is going to be 0, negative 3. Go to the next page and look at example 4. We let G be a graph that is a translation 3 units right and 2 units up, followed by a reflection in the y-axis. So first, I'm going to do the 3 units right and 2 units up translation. So that will be f of x right is minus 3, and then up 2 would be plus 2 on the outside. So let's write this out. I'll have x minus 3 everywhere that I see x in my function. So I'm going to get x minus 3 all squared minus 5 times x minus 3, and then plus 2 at the very end for that up 2. If I distribute this all out, what do I get? You should get x squared minus 11x plus 26 after you combine all the like terms. Now I need to do a reflection in the y-axis. I know that a reflection in the y-axis means I have to plug in negative x everywhere that I see x. So to do that, my function would be negative x squared minus 11 times negative x plus 26. I can write this a little nicer by canceling out some negatives. Negative x squared is the same thing as x squared. Minus 11 times negative x is plus 11x, and then plus 26 stays the same. This is my g of x function. If you're not sure how we expanded this right here, make sure you know how to distribute and FOIL with the x minus 3 squared, and then combine like terms. And if you're lost on any of these other parts, check your journal to see how we translate 3 units right, 2 units up, and a reflection in the y-axis.